Imagine navigating a city without street names or house numbers. That's a network without proper configuration. Network configuration ensures devices communicate smoothly. Let's start with IP addresses. An IP address is a unique identifier for a device on a network, much like a home address in the real world. IP addresses can be assigned in two ways: static, which are manually set and stay the same, often used for servers or printers, and dynamic, which are automatically assigned by a DHCP server and can change. Common for everyday devices like laptops and smartphones. We shall learn more about DHCP, that is, Dynamic Host Configuration Protocol, shortly. IP addresses come in two formats: IPv4, which uses 32 bits, and IPv6, which uses 128 bits to provide many more unique addresses for our expanding digital world. Let's now talk about the subnet mask configuration. Continuing from IP addresses, the subnet mask tells us which part of the IP address is the network, like a street, and which part is the host, like a house on that street. For example, IP 192.168.1.10 with subnet mask 255.255.255.0 means 192.168.1 is the network. The street shared by all houses, that is devices, in that area. The .10 is the host, a unique house on that street. So, the subnet mask helps devices know: are you in my network, that is, in my street, or do I send this data elsewhere, that is, on a different street? Now that we know subnet masks help find which network a device belongs to, let's look at the MAC address, which tells us exactly which device we're talking to. A MAC, Media Access Control, address is a unique identifier assigned to a device's network interface card, NIC. Unlike IP addresses, which can change, a MAC address is permanent, like a device's fingerprint. Routers use IPs to find the right network, but within that network, switches use MAC addresses to deliver data to the correct device. So, when data travels on a network, the IP address helps find the right network, like a street, and the MAC address helps find the right device, like the person in the house. For example, when you're in a coffee shop and connect to the Wi-Fi, your device's MAC address helps the router distinguish your laptop from all the other connected devices. Now that we understand how the MAC address identifies a device on a network, let's talk about what happens when a device needs to communicate outside its own network. This is where the default gateway comes in. The default gateway, usually a router, acts like the main exit from your network to the internet. When a device wants to reach an external site, it sends the data to this gateway first. Think of it like this: your device is a house, the network is your street, and the gateway is the gate to the outside world. Every device is assigned a gateway IP, often the router's address, like 192.168.1.1, which is typically the first usable IP in the network. All devices in the network know to send external traffic through this first house on the street. Now that we know the default gateway helps devices leave the local network, the next step is finding where to go. That's where the DNS server comes in. DNS, domain name system, servers work like the internet's phone book. When you type a website like www.google.com, your device asks the DNS server to translate it into an IP address so it knows where to send the request. Without a DNS server, you'd need to remember long numbers for every website. DNS makes the internet easy to use by handling that for you. Let's see how devices get their IP addresses. This is handled by a DHCP server, or Dynamic Host Configuration Protocol server. DHCP automatically assigns network settings, like IP address, subnet mask, default gateway, and DNS, when a device connects. Without it, you'd have to set these manually for every device. Here's how it works. Your device asks, "Can I get an IP?" The DHCP server responds with an available IP and settings. Your device accepts and joins the network. Most home routers have a built-in DHCP server, making network setup quick and easy, even with many devices connecting and disconnecting.